Well, let's take a look at your MT3 LT6 seminar. Start do the warm-up problems first. I'm not going to go through those on the video. If we look at our state standards here, I want you to, it says for a function that models a relationship between two quantities, interpret key features of the graphs and tables in terms of quantities, excuse me, sketch the graphs showing key features given a verbal description. We want to compare properties of two functions in different ways. And today we're going to look at it graphically and by a verbal description. Your mathematical practice, you're going to be attend to precision. I don't know so much about that, but I guess a little bit. And we're going to look for and make use of structure. We're going to do this today by sketching the graphs of functions. It's kind of be backwards from what we did on our previous lesson on shapes of graphs, where I gave you the graph, you told me about the key features. Now I'm going to tell you the key features of the graph, and you're going to make a graph of it. Let's take a look at our first example here. When you look at the key features, I should say, before we start on our examples, I've got most of them listed here. I couldn't quite fill all of them. We have our max, our min. We want to know when it's increasing. We want to know when it's decreasing. I want to know the x and y intercepts of my graphs. Those all make it nice to do. Now let's actually do that on a problem here. And nice application. In 2015, Christopher Strasser set a new 24-hour cycling record by riding 556 miles in a 24-hour period. The distance he rode over 24 hours can be represented by the function. We're going to sketch a graph that shows the distance traveled, y, as a function of time x. Now, here are some of our key features we're going to be looking at. We know that the y-intercept is 0 because when he starts off, he hasn't ridden any far. We know it's going to be linear. It's going to be positive for anything bigger than 0. It's increasing the entire time. And I know the end behavior, as the number of hours he has ridden increases, the number of miles he's traveled increases. One of the key features of the graph, notice they told us he's going to go 24 hours and he's going to cover 556 miles. So I'm going to use that as my first part of my graph. So I only have to worry about positives because when he bikes, time can't be negative, distance can't be negative. So we were told our time is our x, and our distance, I'll just use d for y. We know when he's done, he's going to have gone 24 hours and 556 miles. So I know here's 24, and here is 556. We know the x and y intercept are both 0. And I know it's linear. So that one made it kind of nice. I just draw a straight line going through those points. There are no relative max or minima, but there probably should be. We weren't just told about it because I doubt Chris drove his bike in 24 hours and never slowed down or never sped up. I'm pretty sure he had to go bathroom at some of those points, get a drink, maybe get some food in him in 24 hours. So this is not quite accurate based on the pic or on the story, but based on the key features we're given, that it is accurate.